Hi there. Trigonometry is one branch of mathematics that is very important. For example, in these two diagrams, we can use concepts learned in trigonometry to find all the missing lengths and all the missing angles. This is Z Online School, and in this video, you and I are going to be looking at the basics of trigonometry. We are going to do this in a systematic way, and by the end of this video, you should be able to know what trigonometry is, what the Pythagorean theorem is, what trigonometric functions are, and at the end of this video, we've got some bonus tips for you. So make sure you watch this video till the end for you to get the maximum value out of it. Let's start with looking at what trigonometry is in definition. The good thing is that the word trigonometry is part of the dictionary. So if you forget its definition, just get a dictionary and look for the word trigonometry. Trigonometry by definition is a branch in mathematics or a type of mathematics that deals with the relationship between sides and angles of a triangle. From this definition, you should be able to pick out that in trigonometry, we'll be talking about triangles. And now about triangles, we'll be talking about how the sides and angles of a particular triangle have relationships. Once you understand this, it will be easier for you to understand trigonometry. You know, I'm only referring to triangles and sides and angles. Therefore, it's very important for you and I to know the types of triangles that are there. I'm not going to look at, obviously, all of them that we can exhaust, but there are some three that are very important in trigonometry. The first is the right angled triangle. This is a triangle that gets its name from the fact that it has a right angle. A right angle is an angle equal to 90 degrees, and in diagrams it will be usually shown by this square here. You can see this box here in the corner, which refers to an angle being 90. Whenever you see this small box in a corner, you know that that kind of triangle is a right angled triangle. Another triangle you should know is the isosceles triangle, a triangle that has got two sides in it that are equal. That is shown by the two lines that you can see on the diagram here. Last but not the least, we've got a very interesting triangle known as the scalene triangle. This triangle is very special. None of the lengths of its side is equal. And like you can see, a different stripe is shown on each of the lines, showing that none of the lines in this triangle are equal. Apart from all these things I've talked about, including these triangles, there's something extra I want to share with you. For the right angled triangle, you should always remember that the longest side in a right angled triangle is the hypotenuse. Another way in which you can remember which side is the hypotenuse is just remembering where your 90 degrees is. As you can see, it's here where we've got the box and going opposite that angle. So this side here is the hypotenuse. Now, when we come to the isosceles triangle, you should always remember that the angles at the base here are equal. Therefore, this fact is very handy in cases where we've been given the angle here and now we're asked to find the angles here. In other videos, we'll talk about more on angles and triangles, so don't worry about getting too much details. But these few things that I'm sharing right now are also very important. For the scalene triangle, you should always remember that the angles inside it, which are the interior angles, are different. So nothing in the scalene triangle is really the same. However, in the scalene triangle, under trigonometry, we still find relationships between the angles and sides. Isn't that interesting? Okay, now let's look at the Pythagorean Theorem. We're going to start with looking at what it is. What is the Pythagorean Theorem? Well, this is a theorem that states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Right from hearing this theorem, you can agree with me that this theorem involves the right angled triangle, because we know the hypotenuse is the side in a right angled triangle that is the longest and opposite the 90 degrees. This theorem was founded by Pythagoras, though some scholars argue that Pythagoras wasn't actually the one who found this relationship between the hypotenuse and other sides. They say that obviously, even before Pythagoras, other people like the Babylonians were using a similar way of thinking. But always remember that this theorem is credited to be found by Pythagoras, and sometimes you might hear it being referred to as the Pythagoras theorem. Now, let's get a closer look at the Pythagorean theorem. What is it? Okay, the first thing, as we know, is that this theorem refers to a right angle triangle. So we need to get the right angle triangle and then get to understand what this theorem is talking about. If the theorem says that the square of the hypotenuse is equal to the sum of the squares of the other two sides, it means that if we label our right angle triangle like this, where we have C as our hypotenuse, B as the shorter side, A as the other side, we can confidently say that C squared will be equal to A squared plus B squared. And now this formula is one formula that is very important, and it might be referred to as the Pythagorean theorem formula if you like. It should be noted that these sides here can be switched depending on whoever wants to switch them, because this is addition. So even if you say C squared is equal to B squared plus A squared, nothing really changes. You might be asking, how did they come up with this? Well, the easiest way I can show that to you is showing you one way in which they prove that the Pythagorean theorem is true. They get a right angle triangle and then form squares for each of the sides. Now, because the hypotenuse is the biggest length of the right angle triangle, you agree with me that it will have the biggest square, right? And the other two sides are going to have smaller squares than the square formed using the hypotenuse. One thing that was found to be a bit special was that if the areas of these two other smaller squares were added, the area that was found was equal to the area of this biggest square. And so they found the relationship that the area of this, which is C squared, if we take the same naming of these sides, so C squared was equal to the area of B squared plus A squared. Actually, this example I've shown you here is one of the ways in which you can prove that the Pythagorean theorem is actually true. With that said and done, now let's get into some calculations. Using the Pythagorean theorem, we can find quite a lot of questions that involve right angle triangles. All these three questions we have here are going to be found using the Pythagorean theorem. We're finding the missing length, as you can read in the question, and we know that these triangles are right angle triangles. You can see that the hypotenuse is 30 and B is 18. In all these examples, B will be my shortest side, and so it will be easier for us to refer to the same sides in the same way. The Pythagorean theorem states that C squared is equal to A squared plus B squared. We have C and we have B. Therefore, we need to make A the subject of the formula. So A squared will be equal to C squared minus B squared. Now we substitute our values for C and B into this new equation that we found. A squared is equal to 30 squared minus 18 squared. You can find these squares mentally, or you can use a calculator. A calculator will be usually faster, and that's what I'm going to use to just show you through the procedure of writing everything in trigonometry on a calculator. Obviously, you know how to find squares on a calculator, but let's do it. 30 squared is 900 and 18 squared is giving us 324. So if you wrote down those answers, you agree A squared is equal to 900 minus 324. We can find the difference on the calculator. So we can say 900 minus 324 which gives us 576. Well and good. So a squared is equal to 576, as you can see. Now, we cannot end our answer here because we have written the answer for a times a, which is a squared. And so we need to find the value of just one a. And to do that, we're going to square root both sides so that we get rid of the square here, because we know square root and square are two processes that are similar but just opposites of each other. So we can say that this square root and the square cancels out, and therefore a is equal to the square root of 576. So we go to our calculator once again and find the square root of 576, which gives us 24. Hence, a is equal to 24 meters. We are done with question A. We're going to do the same procedure with B. However, as you can see, we've been given different sides. We make the letter we want to find the subject of this formula. You can see we've got our hypotenuse, which is C. We don't have B, our shortest side, but we have A. Therefore, we're finding B. So B squared will be made the subject, and it will change accordingly. Right here, you can see that whenever we're finding a side which is not the hypotenuse, we're going to subtract the square of that other side we have from the square of the hypotenuse. B squared will be equal to 17 squared minus 15. 17 squared gives us 289. We can write that in advance. Then we find the square of 15, which should be 225. To be actually faster, you should be able to know at least the squares of the first 15 numbers. In your mathematics paper 1, it will enable you to find answers even faster. So 289 minus 225. The answer is 64. And now, because I know at least the first 15 squares, the square root of 64 will be 8. We can do that in advance. I haven't spent much time on this question because I know you're getting used to the procedure. Just like we did here, we got rid of the square using the square root, and now we found the square root of 64, which is 8, as we may have seen. Therefore, this side here that we don't have is equal to 8 meters. In question C, we don't have the hypotenuse, so we are going to use the Pythagorean theorem as it is. We're not making anything the subject of the formula, as c squared, which is the hypotenuse, is already the subject of the formula. So we're just going to substitute the 4 and the 3. Again, here you can see these are very simple numbers, so we can find this mentally. C squared is equal to 16 plus 9. If you find the sum of 16 and 9, you agree with me, it's 25. So c squared is equal to 25. We need to get rid of that square, and we're going to use the square root to get rid of that. We're going to square root both sides. Then on our left side, because the square root and square are two things that are similar but opposite, so they will cancel out. Therefore, c is equal to the square root of 25. And again, if you know your first 15 squares, you will agree with me that c is equal to 5 meters. Nice and easy. Now, let's look at the trigonometric functions. What are they to start with? Trigonometric functions are functions that relate angles in a right-angled triangle as ratios of two sides. Meaning, these trigonometric functions will also only be used with the right-angled triangle. Now, there are 6 trigonometric functions, but 3 of them are the most important because the other 3 are gotten from the first 3. And now what's interesting is that a lot of people use a special mnemonic to remember these 3 trigonometric functions and which 2 sides they refer to. The mnemonic is SOH CAH TOA. Maybe you've heard it before, maybe you haven't. But the main thing we want to pick out here is you getting to know it. If you forgot it, here it is once again. SOH CAH TOA. If you usually forget this mnemonic, Please, from now on, get practicing it such that you don't forget it. The first letters of each of these words we can say in this mnemonic represent functions. S is for sine theta, C is for cosine theta, and T is for tangent theta. These other letters here represent the two sides that are involved in that particular function. To get understanding about how these sides are gotten, let's refer to a right angle triangle. You agree with me that by now you know what the hypotenuse is. So wherever there's h in this mnemonic, that refers to the hypotenuse. The hypotenuse rarely changes, but the opposite and adjacent sides can change depending on which angle you are using as your reference. What do I mean by this? Okay, let's say this angle here is theta and our angle of reference. It might be an angle we want to find, or an angle we already have and we want to use to find one of the sides in this triangle. If this is our reference, our opposite will be the side opposite this angle. So if we move like that, this side here is our opposite side. And then the side next to this one. So if we move, next is this one. This is what we'll be referring to as our adjacent. Since we've labeled our triangle now, it can be easier for us to use these trigonometric functions more effectively. And if you heard me right, if this angle of reference changes to this one here, it means our opposite will be this one and our adjacent will be this one. Therefore, it's very important that you use the right angle for reference in any of your questions, or else your answers will be different. Now, let's get to see how each of these trigonometric functions are written. We said S is for sine theta, therefore so is sine theta is equal to O to H. Now we know that a ratio can also be just written as a fraction. Therefore sine theta will be equal to O divided by H. For cosine theta, we have the sides A and H. So A will be our numerator and H will be our denominator. The last one here for SOH CAH TOA is tangent theta, which is usually written as tan theta. And it will be equal to opposite over adjacent. These three trigonometric functions are very important. You might forget the other three, but you must never forget these three, because actually we even have a mnemonic for them. There's no excuse for you to forget these trigonometric functions. Now, let's get to see some examples and see how these trigonometric functions can be used. In these examples, we are going to be finding the value of x and theta, or we will be finding the value of x or theta. In the diagrams where we have both x and theta, we'll be finding both of them, while in those where we only have x or theta, we'll be just finding the value for the respective missing things. In A, we are finding the value for x. As you can see, x is referring to this side here. Okay, now, if we think of using the Pythagorean theorem on this question, you see that it can be possible. Why? Because the Pythagorean theorem only makes it possible to find missing lengths. In the Pythagorean theorem, we can't find angles because in that theorem, we are only talking about sides. Now, the use of trigonometric functions enables us to really find the relationships between sides and angles in a triangle, just like we defined trigonometry is. The first step when you're talking about trigonometric functions to be used to answer a question is you finding the hypotenuse, opposite, and adjacent. And if you got the explanation earlier very well, you understand why we're referring to this side as our opposite side, because it's opposite this angle that we're going to use to find x. Now, when picking the right trigonometric function you need to use to find any equation, what you need to see is if the trigonometric function you want to use contains two things that you know and one thing that you need to find. Therefore, in this question, you can see that we've got an angle. All the trigonometric functions involve an angle, which is theta. We've got h, which is our hypotenuse, equal to 11 meters. And now we need to find x. Therefore, our trigonometric function needs to have the adjacent, theta, and hypotenuse. Therefore, we can see that cosine theta is the perfect match for this question. Therefore, cos 50 is equal to x divided by 11. We're going to divide the left side by 1 because we know 1 won't change anything in this situation. And now we have fractions on both sides. Therefore, we can cross multiply and we can have 11 multiplied by cos 50 is equal to x. Therefore, we're going to use our calculator and find the answer for x. The first thing to do is find the value for cos 50. Cos 50 has this value here. We won't start copying it because it will be time consuming. We're going to multiply this answer by 11. And as you can see, the value of x is 7.07066. And as you can see, the values continue just like that. In this question, we've been asked to express our answers correct to one decimal place. Therefore, we're going to round off using this 7 here. And our answer will be 7.1 meters. Now we get to B. In B, we've got x and theta. So some confusion maybe you've gone through is saying, what are we going to use here? Going to use theta or we're going to use the 60? Okay, so in such a question where you've been asked to find an angle and the length, the first question you should ask yourself is, do I have two lengths that will enable me to find theta directly? And as you can see, we don't have two lengths in this diagram. Therefore, we need to use this 60 degrees and the 15, that is two things, to find the third thing, which is x. Like I said earlier, you need to find two things that can be given in your trigonometric functions and one thing that is missing to be able to find that missing thing. First, we're going to label our sides. Note that 60 degrees is our angle of reference, and so our opposite will be x and our adjacent will be the side next to x. You can see that for this question we are going to use sine theta. Why? Because sine theta involves the angle and the side we have, which is 15. We're going to substitute theta with 60 and then O with x and h with 15. Therefore, you can see that the only unknown thing we have is x. And like I said, you should always look for a trigonometric function where you have only one unknown thing. If we used tan theta, we couldn't find the value of x because it uses a and o. Therefore, we'll have two missing things, a and o. If there was a distance on a, we could also have used the trigonometric function tan theta. What's remaining now is finding the value of x. We're going to divide our left side by 1 so that we can also have a fraction there, and then cross multiply and have an equation. 15 multiplied by sine 60 is equal to x. Again, we're going to find the value of sine 60 multiplied by 15 on a calculator. We start with sine 60, which gives us 0.8660. The values keep on going. it's advisable that you also get a calculator so that you can see how to use it. Then we just hit multiply, and our calculator immediately knows that we want to multiply the answer and something. We're going to multiply the answer by 15, and this will be our length of x. As you can see from the answer, when we round off, a 1 will be added to a 9, and when we add 1 to 9, we're going to have 10. Therefore, there will be a 0 here and a 1 added to the 12. Hence, our answer is going to be 13 meters. Now, it's time we worked out the value of theta. Immediately, we change our point of reference to theta. You agree with me that this will no longer be our adjacent side. It was only our adjacent side because we are using 60 degrees as our angle of reference. Since we are using theta as our angle of reference now, our opposite will be this side and our adjacent will be this side. Therefore, we need to change these sides like shown now. Like this, we're going to form the correct trigonometric functions that will give us the correct answers. Therefore, to find theta, we can use the 15, which is h, theta itself, which will be unknown, and x, which we're just from finding as 13. For this question, we can't use the sine theta because we have a side here that we don't know. Therefore, we're going to use cos theta is equal to adjacent over hypotenuse to find theta. Hence, cos theta is equal to 13 over 15. Now, we can go to our calculator and find the value of 13 over 15. 13 over 15 is the same as 13 divided by 15. And so this is our value for 13 divided by 15. Hence, we can say that cos theta will be equal to this value we have on our calculator. Now, one thing you might think is simply saying that since we have cos theta on our left side, let's just divide both sides by cos, and then we're going to have the value for theta. But wait a minute. In mathematics, we cannot just do that as direct as that. We won't be dividing by cos. We are going to say that theta is equal to cos inverse multiplied by 13 over 15. It's very important to note this. Never try to divide this left side by this cos or by a sine or by a tan. We are going to express the angle in terms of cos inverse multiplied by what's on our right side. Therefore, we're going to say theta is equal to cos inverse multiplied by 13 over 15, which we saw on our calculator was 0.866, and there were recurring 6 digits, and therefore we're just going to end it here and round off one of the 6. It's very important to note this difference here. Since cos is multiplied by theta, to get rid of this cos, we're going to say theta is equal to cos inverse multiplied by what we had on our right side. Now, we're going to go to our calculator, and on our calculator, you can remember we didn't get rid of our answer. If you can see, our answer on our calculator has more digits than the one we wrote here. Therefore, if we find cos inverse of this value here, it will be less accurate than the value on our calculator. Hence, we are going to use the value in the calculator without changing anything. How do we do that? Well, if you check on the button for cos, you can see that its second function is cos inverse. Therefore, we're going to hit shift, then the button for cos, and you can see our calculator shows cos inverse. Then, since our calculator stores the answer we're just from finding, we can put ans and then close our brackets. And remember, we need to write our answers correct to 1 decimal place. Now, what you note is our answer is not exactly the same as the answer you would get if you used the principle of angles, where we said the interior angles of a triangle are equal to 180. If you use that method, you find that your answer will be exact. It will give you 30 degrees. But when we find this using trigonometric functions, we have 29.9. Therefore, in such questions, a person who will be marking your working will obviously have a tolerated group of answers. Any answer that can be rounded off to 30 will obviously be marked. Now let's go to C. In C, we're also going to label our sides. We're finding theta at the onset because we have two things that can be used to find theta. You can still use the trigonometric function cos theta is equal to adjacent over hypotenuse, because these two sides that have been given are the adjacent according to this angle, and we know the longest side here is the hypotenuse. Therefore, we substitute cos theta is equal to 8 over 16 after we substitute the value of a and h. And if we simplify this fraction using 8, we can see that 8 into 8 will be 1, 8 into 16 will be 2. Therefore, 8 over 16 is just half. And if we express half, or simply this 18 over 16 as a fraction, you see it gives us 0.5. And so theta will be equal to cosine inverse multiplied by 0.5. This answer is short, so even if we type it on the calculator, it won't be so long. So cosine inverse multiplied by 0.5, which gives us 60. As you can see, this answer is more accurate than the one we had. Later under trigonometry, we'll get to know special angles which are needed to be known for you to be able to answer trigonometry even in your paper 1 questions where you're not using a calculator. Now, we are left with finding the value for x. All that we've covered can make you able to find x using the Pythagorean theorem or using trigonometric functions. So it is your job right now to pause the video and solve for x. You should solve using the Pythagorean theorem and using trigonometric functions. Your answers must not differ in any way, as if they differ, your working is obviously wrong. I'm sure now you've tried out finding x. Let's just see how this answer can be found quickly without me writing anything. I'll do everything on a calculator. If we use the Pythagorean theorem, you can see that we'll be subtracting the square of 8 from 16. And so what we're doing is just 16 squared minus 8 squared. Our answer gives us 192. And we're going to find the square root of 192, because you know that's the procedure. As you see, it gives us 13.85640646. For this particular question, we're going to be using the trigonometric function tan theta is equal to opposite over adjacent, or which is x, will be equal to our adjacent 8 multiplied by the value of tan 60. If we hit equals, you can see that our answer is still the same, and we've proved that no matter which method you use, either the Pythagorean theorem or the trigonometric functions, your answer still remains the same. Again, what I want you to prove is that if you use the trigonometric function sin theta, your answer still does not change. You have successfully reached the bonus tip section. The first tip today is about other useful trigonometric functions that you need to know. Earlier I said there are 6 trigonometric functions, and now let's talk about the other 3. The first is cosecant theta, which is equal to 1 over sin theta. The next is secant theta, which is just abbreviated as sec theta, and it's equal to 1 over cos theta. Cot theta, which is equal to 1 over tan theta. I'm sure you can see the pattern throughout these trigonometric functions. If you didn't see it, let me just pass through it quickly. You can see that for cotangent theta, which is just cot theta. We have a t and a t. Now, for these other two, our first letters are swapped. Cosecant theta starts with c and is equal to 1 over sine theta. You can see there's a c there and an s, while for secant theta, we have s and c. These trigonometric functions, cosecant theta, secant theta, and cotangent theta, are simply the inverse of those trigonometric functions we did earlier. This is why I said it's very important for you to know those three. So if we have sine theta, cos theta, and tangent theta like this, cosecant theta will be equal to the hypotenuse divided by the opposite, meaning we just invert this ratio here. For secant theta, we are going to inverse this, and it will be h divided by a. For tan theta, we're going to invert this, and it will be a divided by o. Therefore, you can use all the 6 trigonometric functions now. The second tip is about the Pythagorean triples, which are just a collection of 3 positive integers that satisfy the Pythagorean theorem fully. Meaning, if you take out 1, for example, in this second Pythagorean triple, if we take out 12 and we use 13 and 5 to solve for the missing side, we'll get 12. If we take out 5 and use 13 and 12 to find the missing number, we'll get 5. With that said and done, you've reached the end of this video, but we're not yet satisfied that you know all about trigonometric functions. If you understood every single detail of this video, you will be able to answer this question with just some of your own logical thinking. You can pause the video and try it out before you see the answers. I'm sure by now you've paused the video. Here are the answers. The answers can be found in 2 ways. The first way is where we just simply relate this trigonometric function that we've been given to the sides here. What do I mean? Let's go to the working for you to understand. In the trigonometric function, we've been given cos theta is equal to a over h. Because we've used x, this is our opposite, this is our adjacent, right? And now they expressed x using the trigonometric function cosine theta, and therefore they used the length QR, and actually we're finding QR. Therefore, this ratio here, 2 to 3, is equal to the ratio of side QR to side PQ. Then we cross multiply and get an equation 3QR is equal to 30. We divide by 3 on both sides and get QR as 10. Another way this can be found is finding that number which was used to reduce the numerator and denominator. We'll do that by forming equations. Since we know each of them had a number that was similar, we are going to put x as that number which was used to reduce, then form 2 equations. Therefore, we can find the value of x if we use the equation 3x is equal to pq, because we have our value for pq, and hence x will be 5. And now if we get back to our equation where we said 2x is equal to qr, we can find the actual distance of qr.